Good morning. It's an honor to be here with the galaxy of, I can say, the aerospace designers in the country, the people who have nurtured the program, taken it from the beginning to what it is today. I see the whole gamut here of the Air Force experts. The talk today is from Tejas, Where Have We Gone? And it is not only Mk2 and AMCA, because there is some other activities also in the naval aviation, so I'll cover that as well, and where we are today and what is our roadmap. So I'll start with, can you go to the next? Do I have control? Okay. So today, Tejas, as someone mentioned, yes, there has been a long gestation period, but today it is a mature platform. We have done more than 5,000 flight test sorties. We have done more than 5,000 flight test sorties without any major incident. The IOC, as all know, was achieved in December 2013 and the FOC in 2019. The first squadron is already formed at Sulur and the second squadron is on the way, almost halfway there. The aircraft has participated now in many international air shows, starting with the Bahrain International Air Show, the Malaysian Air Show, the Singapore Air Show recently, and was quite well appreciated. And it has also performed creditably in various IF exercises like Gagan Shakti, Vayu Shakti, and so on. Some of the accomplishments of Tejas, other than the obvious ones, which is fly-by-wire flight control and so on, it is, we have done trials in all the conditions in India, the hot weather conditions, because these are learning exercises. Operating at 48.5 degrees centigrade, how to make all the electronics work and all that. That was a learning. Takeoff and high altitude, high weather, hot weather conditions in Leh, as well as operating at minus 15 degrees centigrade at Leh and starting the engine without external assistance. Achieving good accuracies with the air-to-ground weapons and integration of the missiles, the close combat missiles and the BBR missiles. All these were learning exercises which have been now imbibed, and we are now ready to go ahead with all these technologies. Air-to-air refueling, again a major technology, was successfully demonstrated with the drop tanks and full transfer in the air. So Tejas is not just an aircraft platform. It is actually a representation of maturity of various fourth generation technologies today that we have achieved. And that is really the takeaway from the Tejas program. Yes, there are a lot of imported equipments on Tejas. It's about 60% indigenous, but there are many imported equipments. But one thing that is 100% indigenous in LCA is the design. And so we have got 100% indigenous design capability in areas like aerodynamic design of such an high performance aircraft, fly-by-wire flight control, avionics, the advanced avionics, the integration of all the weapons, sensors and so on, and the displays. Composites, this aircraft has a very high degree of composites. So that technology has now been matured in the country. Computer control of most of all the mechanical systems, everything is controlled by computers, and that part is also now mastered. Another technology in which many people here in the audience are involved is flight testing of modern prototype aircraft. Those who have gone through it would realize that we took a lot of time in taking small steps because of the uncertainties, the risks, mitigating the risks and so on. For example, going for 20 degrees angle of attack to 21 took almost 2 years because of understanding what is the kind of risk and how to do high angle of attack flight testing. The test facilities required for all these designs are now in place and well established in the country for taking up any further designs of this kind. So all these technologies are key technologies required for any future aircraft design in the country, whether it's Mk2 AMCA or as I said, the TEDBF, the naval version. So this is like the national wealth now we have in this country, which is ready and available for all your future programs. It is not only ADA who has worked. There is the whole nation that has worked for this program. And there's a huge ecosystem created in the country. There are more than 300 work centers, small and large, in PSUs, academic institutions, private industries, MSMEs, and so on, who are actively contributing to this program. And this ecosystem is not what HAL has. HAL for production has a separate ecosystem for the production. This I'm talking is the design ecosystem, which is something unique, which is available in the country today. As far as indigenization, as I said, about half the LRUs are indigenized, but rapidly, more than 91 of the remaining 150 LRUs are under indigenization, and more than 40 are through the Technology Development Fund, where MSMEs have taken up 40 LRUs for indigenization. So that effort is also moving very well in the country. So what next? So the next program after LCA was an enhanced version of LCA, a bigger platform, a more capable platform, which was the Mk2. So this was conceptualized as a replacement for the Mirage class of aircraft. LCA was for the smaller MiG-21 class. And this Mk2 is with enhanced capabilities with AESA radar, internal electronic warfare system. LCA has a podded one. The IRST, MOS, and various other sensors. Enhanced range and endurance with a higher internal fuel, in-flight refueling, and OBOX. OBOX will get integrated in Mk2. OBOX is ready now. A much higher weapon carrying capability, and capability for carrying heavy standoff weapons of the class of Crystal Maze, Scalp, Spice, and so on. As far as Mk2 is concerned, the configuration is chosen, the system architecture is finalized, all the design is complete, and the critical design review is also completed. And the detailed design drawings, more than 15,000 of them, of all the parts, are now ready. So we are ready to go into the prototype manufacturing stage. Mk2 was an interesting evolution. In the beginning, it was felt that let us just re-engine LCA with a more powerful engine. That was the initial thought process. So till about 2014, we worked on that, and a PDR was conducted where a re-engine LCA was designed, which had no significant changes to the basic design, but only the re-engineering part. Subsequently, because of production, ease of production, it was decided we'll go for Mk1A, 83 more, which is the same structure as Mk1. And at that time, it was felt that then the Mk2, now we can move up to the higher grade, a more capable aircraft with a much higher range and endurance to start with. And this implied carrying more internal fuel. To do that, we had to design this aircraft to take care of the reduced instability due to the additional fuel. And that's how the canards came in. There was a lot of deliberation between canard strakes and various configurations. So this was decided finally in 2017. And this shows the maturity of the design process, because the designers now are capable of reacting quickly to changing configurations and coming up with new designs. And finally, in 2019, we froze on a configuration which could carry heavy standoff weapons. So the aircraft was widened, the length was increased further, and this was the final configuration in 2019, for which the PSQRs were frozen. So this had a much more higher capability for payload, internal fuel, and so on. It was a 17.5 ton all-up weight aircraft. The Mk2 incorporates a lot of advanced features, which are over and above the Mk1. Some of them, as I mentioned, was IRST, MOS, but more importantly, the cockpit has been changed completely now. We are going for a side stick configuration to enable a large area display and advanced HUD also in the cockpit. So this is a very modern cockpit, which is coming in Mk2. And it has got, as I said, an internal warfare system. Another important change is the multifunction air data probes in the nose. So we have removed the nose probe, which improves the radar performance significantly. So the probes are all behind the radar. And that is an important change, the multifunction air data sensors. And many more OBOX, in-flight relight capability, and so on. Now, what is important here is all these are new features beyond LCA. LCA design was in the 90s. So these are all the new features which are coming into Mark II, which flow seamlessly into all the future programs. And we had to take this jump because the LCA technology is now, for a new aircraft, we would rather go for the newer ones, as Chief was mentioning also in the morning. And there are many more improvements that have been incorporated in Mark II. These are lessons learned from Mark I. For example, the structural design criteria has been rationalized completely based on the experience of Mark I. To some extent, Mark I in some places was conservative design. So all those conservativeness has been worked out, and we have evolved a new design process for structural design, which helps us to reduce weight significantly. The design has been catered for maintainability and accessibility right from the design phase, which did not happen in LCA. So, for example, using virtual reality tools, the field engineers, field operators from the Air Force actually try out on the VR model whether maintenance is possible, whether parts are accessible, and so on, right in the design phase before the aircraft is made. So that is something we have done here. Another important thing is model-based design. So, for example, drawings are no longer 2D drawings on the paper. They are 3D models. And this was not easy. It can happen easily in your lab, but it also has to happen on the shop floor. The shop floor technician should not finally print out a drawing and start using it. So you have to provide him the tools to be able to see 3D models on the shop floor. And that is what has been done. And of course, design for manufacturability, assembly, which are lessons learned through the Mark I program, DMU, and so on. So a lot of new features have come in here. And all these improvements are actually flowing into all the future programs. And Mark II is a good case study or a good example to implement all these so that all these are also matured for the new programs. And we are at that stage now. In Mark II, this has been done now in the design phase. So the Mark II is a very good stepping stone in the design evolution from LCA Mark I to all the future programs, which de-risk them. So that when we are in AMCA, we concentrate on the stealth technologies and not the basic aircraft design technologies, which are actually matured through Mark II now. So these are the list of all the technologies which are already integrated in Mark II, which will go into the future programs. So the next program that is already underway is the 5th generation AMCA program. And it is a twin engine stealth aircraft. So the new technologies, there are many new technologies, twin engine for the first time. And of course, stealth shaping, an internal weapon bay to carry the weapons in the stealth mode, various materials and radar absorbing structures. And it was decided with the IF that AMCA will be developed in 2 phases, the Mark I with an existing engine and Mark II with an advanced engine, more powerful, which for which the design is underway now. So the current status of Mark II, AMCA is that the configuration is frozen, PDR is completed, and we are entering the CDR stage. By towards the second half of the year, we should have completed the CDR as well. And for AMCA, an SPV is planned, a special purpose vehicle for the manufacturing and production. And this decision has been finalized. The AMCA is, of course, a 25-ton aircraft, all of weight in the non-stealth configuration. And in the stealth mode, it can carry 1.5 tons of payload. And non-stealth, it can carry 5 tons more. And of course, it's a low RCS aircraft. These are the AMCA stealth and non-stealth configurations. So parallel to this, as I mentioned in the beginning, there is a very important aspect of aviation which we are handling through the naval aircraft combat development. This started parallelly with a small team in about 2003 and has progressed. And for this, there have been 2 prototypes which have been built, NP1 and NP2. And more importantly, a facility has been created in Goa called a shore-based test facility, which has the arrested landing and ski jump takeoff completely replicated as on the ship, all the features. And so on this, the LCA Navy accomplished its first ski jump takeoff in 2014. And after that, before we did arrested landing, we did an extensive campaign of high sink rate landings to see the capabilities of the aircraft and to see what has to be improved. There were a lot of iterations here. So almost 400 high-sink rate landings were done at SBTF before finally we did the arrested landing in 2019, September. Subsequently, because of this extensive exercise that was done on SBTF, within about a month or 2 months, by January 2020, we landed on the ship, INS Vikramaditya, and did 18 takeoffs and landing on the carrier. So this gave a tremendous confidence both to the designers and the services that now we had reached a place where we could take up a naval aircraft combat design as well for the Navy. And that's when the Navy came up with the twin-engine deck-based fighter as their requirement as a future replacement for the MiG-29 class and future aircraft. So the TEDBF has been conceptualized as a 26-ton all-up-weight aircraft, a replacement for MiG-29K to start with. It is a stow-bar variant, that is a short takeoff but arrested landing. But at the same time, we are looking at what changes we need to make to this aircraft to make it a catobar variant for the catapult launch. So an advantage of this aircraft is it is designed for our carriers, unlike the other way around. So it's designed for INS Vikramaditya and ISC-1. We have studied the carrier, all the limitations of the carrier, and brought it into the aircraft design to make sure it can operate completely on this carrier. And the first flight of this is planned by 2026. The PSQRs are finalized, and we are in the PDR stage. The configuration of TEDBF, of course, there is one more new technology here, which is wing folding, which also we have progressed with. And that is one extra technology. But twin engine comes from AMCA, the canards come from Mk2, and so on. So it's a consolidation of technologies from other programs as well. So coming to the last slide, everything is not rosy. In fact, many people ask me, how are I handling 3 programs at the same time? Which is a fact, meaning ADA was formed for 1 program, LCA. And now we have 3 programs. So how do you handle it? Now there are a few things which are unique. ADA has about 400 scientists. These 400 scientists, like me in the 90s, were completely unexperienced. We didn't have much experience at all in these things. Now we have a huge pool of very experienced scientists. Luckily, our attrition rate has been very low. So we have these experienced scientists, and now we have a huge pool of manpower available in the industry. And that is how we are working. But one of the important things is proper phasing of the programs. I talked about 3 programs. They didn't happen at the same time. We told the management that you cannot give us 3 programs at the same time and try to do it. It will not happen. So it was phased. There was roughly about a 2 years gap between all the 3 programs as far as our design activities are concerned. The Mk2, the AMCA, and the TEDBF. So there is a 2 years gap so that the core designers can concentrate on one program, take the design to some level of maturity, and then pass it on to the next level. Because any mistakes you do in the beginning of the program will live with you for your lifetime. And that is the critical phase. So that's what we are concentrating. We keep the designers focused on one program. Only when they do the PDR stage and make the initial decisions, then we take up the next. And then the other second run can take over. So this is how we are doing it, by phasing. Another important thing, and we studied the F-35 program. F-35 has got 3 aircraft, A, B, C. If you look at them, they're totally different aircraft, meaning they look similar, but their sizes are different, their characteristics are different, and so on. But what is common there is the systems. About 60% to 70% of the effort is the systems. And today the aircraft is completely computer controlled. So a commonality of those systems helps a lot. And this is what we drove to the users, insisting that we have to strive for commonality. It's not that each user comes and says, I want something else. Why do you want something else? So we work that way, and we have made sure that only essential changes are done between various programs. So we have systems which can be matured and can carry across to different aircraft programs. To do this, of course, the next part is very critical. The designs have to be modular. It is not the aircraft structure. I'm talking about all the computers, all the systems, even the sensors, which are designed to be modular. So you can very quickly add a capability by adding a new card, for example, or even in the radar. by adding a few elements, you can increase the capability, but the basic building blocks remain the same. And this is a key feature. So the modular design of both hardware and software. And lastly, as I said, today we have a huge manpower base available in the country. There are many companies ready to work in design and assisted in design. Some of them would like to work independently. We are given some work packages for some areas, but in many areas they work with us by having engineers with us. That way their expertise grows and we get support of this manpower. And the outsourcing of design activities is a very, very critical aspect, which was missing in the LCA days. There was nothing outside. So today that is one force building feature, which we are using very effectively to handle these programs. I think that is what I wanted to say. Thank you very much.